Hello everyone, welcome to the session. This is Sudeshna, Assistant Professor of CSC Department. In this session, I would like to give you some information on process concept of operating system course. Now, at the end of this session, you'll be knowing the differences between program and process, structure of process memory, and process states. So first, let's see the differences between program and process. Program is defined as a set of instructions which are used to carry out a specific task, whereas process is also a program which is under execution. Program is called as a passive entity, process is called as an active entity because while running it will be requesting some resources, it will be requesting the CPU, etc. A program has a longer lifespan. It means once a program is created, it will be stored in the form of a file in the secondary storage, example on the disk. And until it is manually deleted, it will be there in the disk. Whereas a process has a limited lifespan, means it will be created when the execution starts, and as soon as the execution is finished, the process is terminated. A program does not contain any other resource, whereas a process contains some additional resources like memory, address, disk, printer, etc. A program requires memory space on the disk to store all the instructions, whereas a process contains memory address which is called as address space. Now let's see the structure of process memory. Initially, when a process is created, it will be assigned some amount of memory by the operating system. Now the process will utilize that memory which is given by the operating system in an efficient manner. So for that, it will divide the memory into four sections like this. Now if you'll observe, the bottom two sections called text and data are fixed in size, whereas the other two sections called stack and heap, they are not in fixed size, where it means that stack can increase its size and decrease its size. Similarly, heap can increase and decrease as per the requirement. Now let's see what are these four sections used for. Now, the first section called as text section is basically used to store the data about the program counter register and other registers which are used by the CPU for execution like program counter, uh, registers, accumulator, stack pointer, etc. Next, stack is used to store some local variables and also used to store some temporary data like function parameters, function return values, etc. Next, data is used to store the global variables. And the last, heap is basically used to store dynamically allocated memory. Now, while running, the process may request some additional amount of memory in execution. That dynamic amount of memory requested while running time is actually allocated from heap area. And for this request, it should use some methods like malloc and calloc. Now let's see what is a process state. As we have seen, a process is nothing but program under execution. So when a process is created, the program will start its execution. Now once the program is done with its execution, the process will be terminated. So these are the two states that we have come across till now. In addition to those, there are some more states which a process will undergo. So as a process executes, it changes its states. Now each process may be in any of the following states. So basically there are five states like new, running, waiting, ready, and terminated. Now let's see the process state diagram, which shows all the states of a process. Now initially when a process is created, it will be in the state called new. Now, once it is ready to execute, it will be moving from new state to ready state. Now, in the ready state, all the processes which are waiting to execute will be waiting in the queue. Now, they are waiting for the CPU to execute. Now, once the process which is there in the ready queue gets the CPU, it will be moving from ready state to running state. Now, while it is running, it will be like it has three options for, which will be moving from running state. Now let's see what are the three options when it is in running state. The first option is When it is running, it may successfully complete its execution and it may stop. That is, it may go to terminated state. That is, on exit, it will go to terminated state. This is first option. The second one is when it is running here, it may come across some event to happen or some IO request, that is input output request. So if it wants some input output, then what it will do is it will stop its execution here and it will go to a waiting state. So here it will be waiting until this event happens or else until it gets its input or output event. So once it gets that, it will again go to ready state where it will be waiting for the CPU. This is second possibility, that is waiting. The next thing is when it is running, in between it may be interrupted by some process which is having higher priority. So imagine that there are two processes. The one which is running is lower priority and the one which came just now is called as higher priority. Now the process which is running here should release the CPU for the higher priority process which is waiting here. So what it will do is it will release the CPU here and it will go to ready state. Whereas the CPU in the meanwhile is given to a higher priority process. So when it is waiting here, it may be given signal that the one which is running till now has completed. In that case, it will be moving from ready state to running state. So these are the three possibilities that it will come across at running state. Either it will successfully executing, or it will be waiting for some IO event, or it will be interrupted by some higher priority process, and so on. So these are the five states of a process. So this diagram is called as process state diagram. So I hope you people understood all these three concepts. Thank you all.